So in today's video, we are going to focus on Poisson distribution. So Poisson distribution is one of the probability distributions that we have among discrete and normal sampling. So today we are going to focus on Poisson distribution. So let's start by doing this example of Poisson distribution. We'll understand it better. And properties of Poisson distribution will identify them in this question. So we are given a statement. They say that in this statement there is only 14.04% chance that exactly 3 lease agreements will be signed on a given day, when the average number of lease agreements signed per day is 5. When the average number of lease agreements signed per day is 5. Now, the properties of Poisson is that there is a given time. There is time interval in each and every statement of Poisson distribution. And where you see the average number, you know that the average number is mean. So in this statement, we are given that the average number of lease agreements signed per day is 5. So we know, let's highlight it. Let's highlight it with green. When the average number of lease agreements signed per day is 5, okay, we know that our average is 5. And this 5 automatically we know or is mean, because in Poisson distributions where you see average, you know that they want mean. And mean is always denoted by mu. That's why here we said mu is equals to 5 from that given statement. Here first comes the question from this statement. What is the probability that on a given day the Durban branch will sign at most 2 lease agreements for office? At most 2. Let's highlight at most 2. Yeah, at most 2. At most 2. If you want to understand probability better, in each and every statement, read these statements carefully and make sure that you analyze them. So now we know that at most 2, simply we want less than equals to 2, each and everything below 2, including that 2. So what is the formula that we are going to use? The formula of Poisson distribution probability is that the probability of x is equals to mu exponent x times e. This e you will find it on calculator to exponent minus mu divided by x factorial. So this mu here is the average. That's why here we said average. If you don't write mu in this way, you may write it as average, but we know that average in Poisson distribution is mean, and this thing here is mean also. So now this e, you are given it on a calculator. So if you want to press it on calculator, you just press shift and you go to, there is a button below log that is written in. From there you press shift and in. From there you will come up with this creature e. So since they say what is the probability that at most 2 lease agreements will be signed for the office, now we are sure that, and I said the probability of each and everything less than 2, we add each and everything less than 2, including that 2. So that's why we said the probability of x equals to 0 plus the probability of x equals to 1 plus the probability of x equals to 2. So what is the probability of x equals to 0? In other words, what is the probability that they will not sign even 1 lease agreement? 0. That's why we said here, where there is x, we are going to put 0. You just copy the formula. Where there is x, you write 0, or if it was 5th number, you were going to write 5. So that x is the number of outcomes, So that's why here we said 5 to exponent 0 times e to the exponent minus 5 divided by 0 factorial. Now, what you must know in Poisson distribution is that don't forget that 0 is number, because 0 factorial is equals to 1. 0 factorial is equals to 1. So don't say, right, this thing does not exist. It exists, since we know that 0 factorial is 1. So here is our mu, our average. That's why we said minus mu from this formula, and our average was 5. From there, when we punch this thing, all of it in a calculator, we got 0,0067. We run through 4 decimal places in this example, but it depends what the question says. Since you are writing exams, they will tell you from the start, round to 3 decimal places or 4 or 2. But most of us, we are common with 2. So in this example, I just wanted to make sure that I cover everyone. That's why we rounded to 4 decimal places. We are done with 0. Now, what is the probability that x will be equals to 1? They will sign one lease agreement. 5 exponent 1. Where there is x, you substitute 1. Since now we are on 1. That's why we said 5 exponent 1 times e to the exponent minus 5 divided by 1 factorial. Then our answer was 0,0337. Our answer was 0,0337. Lastly, let's scroll it down. Yeah. From there, lastly, what is the probability of x will be equals to 2? Where there is x, you substitute by 2 from that formula. Where there is x, you substitute by 2. From there, that's why we said 5 exponent 2 times e to the exponent minus 2 divided by 2 factorial was equals to 0,0842. Now, if they said, what is the probability of signing no agreement, then you were going to use this 0. What if they said, what is the probability that the Durban branch will sign only 1? You are going to use this one. If they said, what is the probability that the branch will sign 2 lease agreements, you are going to set the probability of x equals to 2. Now, but the question says, what is the probability that on any given day, the Durban branch will sign at most 2? That's why this sign here symbolizes at most 2. Let me scroll it down further. At most 2, which is less than equals to 2. From there, we found all of them. It included 0, 1, 2. Less than equals to 2 include 0, from 0 to 2. That's why here we added all these probabilities that we found here, which was 0,067 plus 0,037 plus 0,0842. Our final answer was 0,1246. Now, this is the final answer. This is the answer that they want here. What is the probability that on any given day, the Durban branch will sign at most 2 lease agreements for office space? The probability that at most 2 lease agreements will be signed is 0,1246. Now, let's go to the next question. Here comes the statement. John's answering machine receives about 6 telephones between 6 a.m. and 8 a.m. What is the probability that John receives more than 1 call in the next 15 minutes? I said that in Poisson distribution, they will always give you a time interval. Here, our time interval is 15 minutes. 15 minutes. Then the statement further continues that let x equals to the number of calls John receives in 15 minutes. The interval of interest is 15 minutes. In each and every Poisson, we will be given a time interval. We are given that our time interval is 15 minutes. Now, what is our average? Since here they did not mention average. Since we know that John receives six telephone calls in 2 hours. Now we are going to use this formula. Average number of calls received in every 15 minutes. They tell us that in each and every 15 minutes, there are 6 calls. I mean, in each and every 2 hours, from 6 to 8, there are 6 calls. Now, since we know that our time interval is 15, we are going to want to how many 15 minutes are there in 2 hours. That's why we said 6 divided by 8. This 6 is for 6 calls. This 8 comes from how many 15 minutes are there in 2 hours. 2 hours is 120 minutes. 120 minutes. That's why we said 15 divided by okay, let me say it this way. How many 15 minutes are there in 2 hours? 15 minutes that are there in 2 hours. We discovered there are 8. Since we know 15 plus 15 is 30. 4 in 1 hour, 4 in 1 hour. That's why we said 6 divided by 8. This 8 comes from how many 15 minutes are there in 2 hours. Since we know that in each and every 2 hours there are 6 calls. Then we said 6 divided by 8, which is equals to 0.75. 0.75. This is our average. If they didn't give you an average, you must know how to find the average, because it's not every question that they will give you an average. If you are not given an average, you will be given a time interval. If you are not given time interval, you will be given average, like the past question that we did here. They didn't give us time interval, they gave us the average. Now here we found our average, which was 0.75. Now comes the question, what is the probability that John receives more than one call? More than one call. Let's highlight it. More than one call. More than one call in the next 15 minutes. More than one call. More than one call. Let me highlight it. More than one call. Let's use this color. More than one call in the next 15 minutes. Wow. More than one call. We know that's more than. We don't want anything less than equals to 1. So here we are going to apply the complementary rule. This is one of the rule of probability. The complementary rule says 1 minus the probability of x less than equals to 1. Don't forget, when we say the complement of A, we mean not A. When we say what is the probability of the complement of C, we mean not C. That's why we said 1 minus the probability of x less than equals to 1. Since our statement said, what is the probability that John receives more than one call? Automatically they say not less than 1. Not less than 1 or equals to 1. So here is how we attempted it. We started by looking for the probability of 0, not receiving any call. What is the probability of that John may not receive any call in these 15 minutes? 0. We said it is 0.75 to exponent 0. You just use the same formula. Where there is x, you place 0. That's why here there is 0. 0. From the 0.75 to exponent 0 times e, the exponent minus 0.75 divided by 0 exponential. I mean 0 factorial is equals to 0.4724. We are done with 0. From there we are going to 1. What is the probability that one call will be received in 15 minutes? We substituted 1 where there was 0. Where there is x, you just place 1. That's why here when we placed 1, we got 0.3542. Now, excuse me, yeah. Now, since they said just receives more than one call, what is the problem? That more than one call will be received, not 0 calls, not 0 and not 1, more than 1. We are going to add them. The answer that we are going to get, we are going to subtract it from 1. The answer that we are going to get, that is the probability that they want. That's why we said the probability of x is greater than 1, more than 1, is equals to 1 minus 0.8266. Where is this? Where do we get 0.8266? We get it from 0.4724 plus 0.3542. Then that's how we said 0.8266. We subtracted it from 1. Now, what is our final answer? Our final answer is 0.1734. So this is the probability that they want, not these ones. These ones, they lead us to the answer. So our final answer is 0.1734. So thank you very much, guys. Feel free to comment if you didn't understand somewhere. Feel free to comment or to ask a question. Thank you.